Hi guys, we're going to discuss a summary of what the class notes, the group discussion that you did on the wonderful intro to calculus. So taking a look at this, what we want to do is we want to talk about this idea of, what we were examining in this activity. And one is the first main idea was this idea of what is called the average rate of change. And the average rate of change is a pre-calculus skill. This is something that we did in pre-calc last year quite a bit. Change in y over change in x, slope of a secant line. So pretty straightforward idea in this problem. So when we're taking a look at this, the change calculated over a measurable interval. And it doesn't have to be time. Like notice that in this case, our change was a change in distance based on a change in the consumption of gas. So whatever is on the x-axis, the change in x, does not have to be time. It can be anything that it is talking about on the x-axis. We're still this idea of looking at a slope, change in y over change in x, but it doesn't have to be time. Although a lot of times it doesn't have to be. Our interval that we had goes from the first x to the second x, and that first x is the gas you had consumed at the beginning of that time frame that you were looking at, and then how much gas you had consumed by the end of that. So that we're looking at the difference in gas consumption, which would be the gas consumption on that trip that we had done. And notice that, again, this is not time. So that's something to kind of look at, to not be forcing something to always be time. Pay attention to what your units are on the x-axis and the y-axis as we take a look at it. So this idea here is that we're looking at our change in slope formula, change in y over change in x. So we have our regular slope formula. Here it is with your function notation. Change in distance traveled over the change in gas consumption that you have. And so if you were looking at your graph for that, and I just was like looking at a sample graph, kind of looking at it, maybe not realistic, but a sample graph, that if we have the x-axis here is our gallons of gas consumed, and then our y-axis is our distance traveled, whatever function we have that describes this relationship, that what we're calculating when we do an average rate of change is we're drawing a line, a secant line, in between the 2 points. And just for your fact of the day, the secant line is named secant line because in Latin, if you look at the Latin root of that word, I think it's pronounced secare, but I don't know. Whoever's taking Latin can speak to that. But that means to cut. So it is a line that cuts through the curve and hits it in 2 points. And so this idea is this slope that we're looking at, total distance traveled divided by total gas consumed that we're looking at on the trip. All right, and then we wanted to investigate what happens as delta x goes to 0. And so if I take a look at that on Desmos, I did a little activity here on Desmos that kind of as you're looking at it, and let me find there it is, that what you can see here is that first secant line point. And then kind of as you are, let's see if I can move that over just a little bit so that you can see it. There we go. That as I click and drag on this, you can see that as the bottom point down here at this bottom starts to get closer and closer and closer to that point, all right, what we will see is that the secant line is approaching what is basically a tangent line. And so each time we're calculating this, so like for example, if I put the points that close together, what you can see is that's a pretty good estimate for kind of what the slope of a tangent line would be. It shows us that it is approaching that. And the closer, of course, that I can get these 2 points here and here together, then the better estimate that's going to be for quote unquote the pseudo instantaneous rate of change. All right, so then we get down to this idea of instantaneous rate of change. And so basically now we're getting into what is considered to be the calculus skill of this. And that the idea is that when we are looking at the change calculated in one instant, that the change in distance traveled at the instant our consumption is 13.2 gallons. Like, what actually is happening there? What is our rate of change at that moment? And that rate of change at that moment is represented geometrically by the slope of that tangent line. So when we look at this, our delta y and our delta x, they actually both approach 0 as we get closer and closer and closer. You can kind of visualize a little triangle, and that as the 2 points get closer and closer together, that triangle gets smaller and smaller and smaller and smaller, and the delta y and the delta x are both approaching 0. Now, we both know, or we all know, hopefully, that division by 0 is undefined, and that's why we can't directly calculate this instantaneous rate of change, because we only have 1 point. And so this 0 over 0, it's an undefined number. It's because of division by 0. It's actually called an indeterminate form because we don't know what's actually happening, because we're not truly equal to 0 over 0. What we're doing is we're allowing things to approach 0 over 0, and that is what is called a limit. And this limiting process, when we result in this approaching 0 over approaching 0, it's considered to be an indeterminate form. And the slope of the tangent line is not going to be undefined. What's going to happen is we're going to use the limiting process, which is what calculus is about, that applying these smaller and smaller increments to create a limiting process, that this will allow us to examine what the true slope of that tangent line is, even though we cannot calculate it directly. All right? And just to kind of as a definition, the limit is the resulting value the function is approaching. So if I'm looking at as delta x approaches 0, what I'm trying to do is to see what the slope is approaching as the tangent or the secant line turns into a tangent line. Now, when we apply this limiting process, and let me just scooch down just a little bit, basically what we do, and this is also kind of some naming conventions as we do this, sometimes we'll call this point x and x1 and this point x2, and that will give us that x2 minus x1 when we do delta x. Sometimes we'll just simply call the first point x. We'll talk about that we've gone h over, and so this point would be x plus h. It's the same thing, we're just naming it differently. Sometimes we don't use h, sometimes we just simply call it x plus delta x, the original x you had plus the change in x to get to that point. So those are all different things that we're going to be talking about in terms of identifying these 2 points. They get closer and closer together. And so the limiting process is something that can't be calculated directly, but we can approach by doing successively smaller and smaller increments, and that will allow us to take a pre-calc skill of average rate of change and apply the limiting process and determine the actual quote-unquote answer to our instantaneous rate of change problem. And one of the things also kind of as we take a look at this idea is if we go back into the group discussion that you guys were talking about. So, and I just made some little notes over here on the side. So in here, here's the key, and I'll distribute this to you guys so that you can compare that to the answers that you came up with in your group. But in calculus, there's the top right was the, this one right here is going to be what was the average rate of change. It wasn't really changing, it kind of just stayed the same the whole time. That's because that's calculating over the long term. And then the one that was in the lower left right here, that one was changing as the car was driving. And so what we know, because it was changing more on an instantaneous basis, that is what's called the pseudo-instantaneous rate of change. That can't truly be instantaneous because what it's doing is just simply taking a very small increment of change in X, and like in your gas consumption, whatever it can measure, and then using that to calculate the slope of a very tiny, tiny difference between 2 points in the curve. So your car doesn't actually do calculus, your car is doing pseudo-calculus, which is it's kind of looking at this idea of a limiting process and picking something fairly small. Now, in terms of your slope, your average fuel efficiency that we calculated over here, it's an average rate of change, so basic slope of a secant line. And then I added in here that at the moment, like when we were looking at what was happening at the 74.4 miles per gallon, that in that, what's probably happening is you're just not using much gas. You're idling, you're coasting, you're sitting still, the car's just running but not moving, different things like that. And that what's basically happening, that it jumps up to 74.4. But remember that kind of the idea is that it could be going to infinity because we have to let the increments get smaller and smaller and smaller. And it may be that that's the limit or the tangent line that the car is just sitting there. Maybe that's your baseline consumption of miles per gallon is going to be the 74.4 when you just sit there and just let the engine idle. I mean, we don't know that. And again, this is that idea that when we do the limiting process, we're heading toward this indeterminate form of 0 over 0. I like to call it the do more work form because every time we see it in calculus, you are going to do more work to investigate, and that do more work involves some calculus techniques. And that's the idea of where we're going to be calculating instantaneous rates. So instantaneous rates are hard to calculate just using slope, but they do apply this idea of a limiting process that's there. All right, and then down here at the bottom, this is just talking about kind of the idea that your average is a long interval that's easily measured. Your instantaneous are repeated calculations of shorter and shorter intervals that's not quite as easy, and that theoretically we're letting the change in the gallons of consumption of gas go to 0 and get as close to 0 as possible, and then we're going to use that to help us guess what is happening with that. All right, so that will end up our teacher summary for that. There are some other things that you're going to be doing for homework. So you're going to take a look at the videos that I have posted. Make sure that you go to your Schoology page, take a look at the assignments that I have for you. You're going to be working on the Check Your Understanding from this. That's part of your asynchronous classwork. And you can work together in your group in Zoom, that's fine, but you're going to be working on that for the finish out the class of the day. Then you are also going to put that on your own paper, and you will submit that through into the OneNote notebook. So just to remind you of what's going to happen for that, let me do this down here. I'm sharing my screen. That over here, down in your notebook, whoever's notebook it is, and I'll just use the first one here, you're going to go into the homework. You're going to find the Check Your Understanding for that. And then what you're going to do is you're going to insert above. So I'm just going to remind you how to do that. I like to kind of move this down a little bit because I don't want it to be in the same box that's right there. So I just move that down, click right there. You're going to go over to Insert and Picture, and then you would navigate to wherever you have your picture from your camera, from online, from your file if you saved it to your computer, and make sure that you take a picture of the entire picture of your homework page. So you're going to do this Check Your Understanding on your own paper, in your own handwriting. Make sure you sign and put your name at the top of it to pledge that this is your own work, and then you will upload that picture right here so that when right here, so I figure out which computer I'm using right here, so that way when I go to speed grade through these, I can just look at it and see that you've done that. Your other homework for tonight is this watch the video. That's going to be through Schoology. Make sure you click on the assignment through Schoology because it's through Edpuzzle and it's recording that you are watching it. And there are some exit ticket questions at the end of that for you to answer. So that's pretty much going to wrap up today's lesson, and let me know if you have any questions. I'll be in Zoom throughout the class period, so if at any point you're ready to come back in and maybe ask me some questions while you're working, feel free.